Good evening, everybody. My name is Kevin. Welcome to the ESP32 product creation journey, where we are going from concept to product using an ESP32 module. We're doing everything from hardware design and development and creation through firmware writing, as well as back-end software, web service stuff. And right now in the process, we're still in the hardware dev firmware side of things. And today specifically, I want to show how we're going to add unit tests to our firmware. And so this is something that I am admittedly new to in the firmware realm. I'm quite experienced in writing unit tests for software development projects, for my regular job. But on the firmware side, I think it's crucial to have these, and it's a little different than writing unit tests for your, let's say your JavaScript project or your Python project or C# or whatever it may be. And so I spent hours researching how to do this particular setup, which I'm going to try and walk through again from scratch to show it to you to maybe help save time in your project. And so I'm going to preface all of this with I'm still learning how to do this in the embedded side of things, including with ESP specifically, which is what we're using as our development environment for this project. And so, first of all, unit tests, for those that are not aware, are just a simple way for you to run code against other code that you've written to test its functionality so that it, has the desired outcome. Now, for hardware, this gets a little different because I'm going to call it two kinds of unit tests, but I'm not going to refer to them both as unit tests, although they are referred to unit tests like this, which to me is a misnomer. I'll explain that here in a second. But if we come to the ESP IDF documentation, let me drag it over here, maybe, if it'll let me. Okay, here we are. This is the IDF documentation, and there's a whole section here under, let me show you where it's at so you can find it, under API guides called unit testing. And I don't consider these unit tests, and I'm splitting hairs like I'm being pedantic here, like they are by technicality unit tests, but let me explain where I'm going with this. So unit tests to me in C++ code, which is what we're writing most of the code in for our product, can be executed anywhere in any context as long as you have a C++ compiler and the source code that is under test. And so all of the firmware that we're writing over here, and I'm using VSCode, you can use whatever you want, but all the firmware that we're writing will be able to be tested with just simple C++ code anywhere, like on a CI box. Doesn't have anything to do with the hardware, and part of that is because of how I'm abstracting the code. There are certain things that are definitely tied to the actual chip device level, like GPIO and the SPI port and things like that. But everything else, the business logic of the product, is just C++ code. There's nothing device specific about it, and that's by design so that it can be portable, so that when we do things like write it originally for a P1 and then decide later that we want to use an ESP32 module, we can port most of the code and just update the device specific parts. And so for me, I'm going to call unit tests, for our purposes, those tests that can be exercised by any machine that has the source code under test and a C++ compiler. And so I'll run those on like a Jenkins box or something like that, whatever. We'll get to that later. But in the context of the ESP-IDF documentation, unit tests to them are on device. Like this will compile as a separate executable binary that you'll program onto the ESP32 itself and run tests, which is also very important because now you're running on raw hardware. Like you're in the actual execution environment of the end product, which is also a good thing. However, unnecessary for, iterating on regular unit tests. And so what I'm going to call these that are running on the device, I'm going to call those integration tests. And you can argue with me about the naming of that or what I call them. That's not important. Sparky, what's up? Thanks for joining. Really appreciate you. And so I want to talk about both, but today I'm going to focus on the C++ unit tests. Now, and I think we're going to play with these ESP-IDF tests later, again, in more of like what I would call an integration test, where I want to maybe have one that exercises the display or does some things with the power circuitry and things like that, not testing the business logic of the product itself. And so how do we do that? Well, if we're talking about regular tests with just that are C++ tests, there are lots of frameworks, and we can probably just show that really quick. C++ test frameworks. I think there's a Wikipedia entry that list of unit testing frameworks. Like if you've ever been to this page on Wikipedia, there are just so many. I think we just go to C++, click on that, and you will see that scrolling forever, there are a lot of C++ test frameworks. And so you can come to here and choose whichever one works for you. What I'm going to show you how to set up, hopefully, fingers crossed, like I said, I spent hours doing this yesterday and I want to kind of walk through it again, is how to do this with the Catch C++ testing framework, Catch2. And let's just go to the repository for that. You can see it here. It's at catch.org/catch2. It is a very simple C++ test framework that can be header only, and I might play with that, but that's probably not how I'm going to show you how to set it up today. But so let's walk through it. Go through the steps, and like I said, hopefully it can help somebody else in their project not spend as much time as I had to yesterday to figure this out. So as a brief recap, this, and it's a little small, so you might want to just go into full screen mode if you're watching this. We have our project structure over here is we have this components folder, which have all of the components that we've written. So far, the only ones we've written are this logging and serial logger. And that was, again, in a previous episode where we got the firmware logging created. This DTF update manager you can ignore. That's something I'm working on right now that we'll get into on another stream. And then you have a main, and it has a main.cpp. This main.cpp is where, again, just in a loop here, every 5 seconds, we are using our new logging facility to say, hello, statfeeder world, and just increment over and over and over. And the way that ESP-IDF builds all this is with Cmake. And that's why you'll see these Cmake lists.txt files everywhere. There's one under main, there's one under the logging component, there's one under the serial logging component. This is part of the ESP-IDF build system that tells IDF how to build your firmware. And it has, it's a sort of specialization of Cmake, because this IDF component register is not a Cmake raw command. It's one that is added because I have the ESP-IDF installed. And so let's come into Cmake. Yeah, so but if you look here, this Cmake minimum required, include, project, these are all, keywords in Cmake. And so I'm not going to go through the whole build system of Cmake. There is a learning curve for sure. You'll have to push through that. But this is our project as it exists today. It builds and it prints out that statement every few seconds. And so what we want to do now is add unit tests. And so the way that we're going to do that is we're going to use Cmake as well. And so when you come into and you do an idf.py build, that's basically a Python wrapper around Cmake. And so that does a whole bunch of ESP-IDF Cmakey things to build your firmware. It spits it out, and then you can flash it onto your device. So we're going to use the same mechanism to build our tests. And so let's get right into it. Hopefully it won't take us very long. So the first thing that we need to do, and I don't love this, and I'm trying to think of better ways to do it, but for now, this is the way to work. The way I've gotten it to work is we need a separate folder to house our Cmake tests project. So I'm going to create a new folder, and I'm going to call it unit tests. You'll see test and tests, but I'm specifically using unit tests for a reason that we'll see later, which actually let's just mention right now because we're not going to mess with it today, but I just want to give insight into why I'm doing it. It says unit tests are located in the test subdirectory of a component. And so for IDF, up here in let's say our logging component, if we put a folder named test, that's where the built-in IDF mechanisms are going to look for those, what I'm calling integration tests, on-device tests. And so I'm going to try to call these out as separate as unit tests. And so I've got that folder created. And then I need to create a Cmake list because that's the Cmake way. So I'll do a new file and I'll say Cmake lists.txt. And it's empty. And this is where we're going to specify what we want to build for our unit tests to run. And so I'm going to copy some boilerplate here and I'll explain what it means in a minute. So you don't have to watch me type these things. So at the top of every Cmake list.txt root file, so like you'll notice in this one, we have a Cmake minimum required, and we name this project StatFeeder firmware. But if we look at the Cmake lists and logging, it doesn't have any of that thing. So the very top level Cmake list text will have the version required, and we have to give it a project name. And I'm going to modify this slightly to be StatFeeder firmware. I'm just going to say StatFeeder unit tests. Languages CXX is how we're indicating that we're going to be, these are going to be written in C++, so it helps the build system know that that's what we're working with. Okay, now we need to get the Catch2 testing framework somehow installed. And there's a bunch of ways to do this, and I'm still torn on which way I think is best, but right now, Catch2 is in an interesting scenario. If you come to the raw github.com catch.org Catch2, you'll notice normally you'll see like a main or master branch here or a version. Right now it says devel, which stands for development. And there's a note that says you are on the devel branch where the next major version, v3 of Catch2, is being developed. As it is a significant rework, you will find that parts of this documentation are likely still stuck on v2. What's interesting is that they've decided to make that the main branch of the repo, which I've never seen before. Normally, you don't switch a development branch to be the main branch until it's ready to be the main branch. But it seems stable enough, and it's the future of Catch2, and so I decided we're going to use it, which is kind of weird. Normally, I don't do that. Normally, I'd stay. But there's enough changes that I'm going to just go through the learning curve now, and once v3 is finally the production release, I'll be ready to go. But it says, and this is important, for stable and document matching version of Catch2, go to the v2 branch. The documentation is still very much v2. And so the things like even the getting started tutorial, just as an example, let's go over to this. Like it'll tell you to do things like define catch config main at the top of only do this in one seat. Like that doesn't apply to the new v3. And I went through all of this last night, so I'm going to save you the time on that. So this will be for using the v3 version of Catch2. Now you can install it as a header only. So like you can get, if you come up to, I think it's the tutorial here, you've got this amalgamated header and amalgamated source file. You can get it that way. You can actually install it with like a sudo apt install and install it at a system level. I don't love that because then it creates, you know, what version is running on what machine and you have to manage it at a system level. And so I'm going to install it via just cloning the repo. And I may change this to be a submodule, a Git submodule, so that I don't have to have all of that in the source code repo of the firmware, but that's how we're going to start. And the way we're going to do that is we're just going to come up to the main here, and we're going to click on this get code, and I'm just going to grab the repo URL, come over here, and then I'm going to cd into our unit tests folder. I'm going to create a directory called lib, cd into lib. And I believe I can just git clone from here. Let's see if it comes down the way I'm expecting. I think it should create a Catch2 folder and then dump it into that. So let's do that and see what we get. Yeah, okay, great. Okay, and so now you can see under my unit test folder, I have a lib, Catch2, and then this is the whole repo. And like I said, I don't want to check that in to my repo, like another whole repo. And so you can do things with submodules, which I'll play with later. But again, you can do this via single header this way, or you can install it at the system level. But I'm going to show how we do it this way. All right, so I've got my lib Catch2. And so now all I need to do is a couple of things. I'm going to get rid of that line there. We need to do what's called an add subdirectory, which tells Cmake, go into this subdirectory that I'm about to specify, which will be lib/catch2, and look for a cmake list.txt file there and add that to my project. And so if we come under here to Catch2, you'll see there's a cmake lists, and it's got a whole bunch of things in it that tells Cmake, this is how you build me, essentially. Okay, and I think to start off simply, we can do add executable, which is telling Cmake we want to output an executable that we're going to call unit tests. Just like that. And then in that, we need to link Catch2 in. So we're going to say target link libraries. These are all just Cmake isms if you're following along. And we need to say, what do we want to link libraries into? Well, we want to link it into unit tests. And the libraries that we want to link in are Catch2. And we're going to specify this a certain way, which is Catch2 with main. And this tells, when we link in Catch2, we're going to link it in with a main function already built in so that when we run this new executable unit tests, we don't actually have to write a main entry point. So you'll notice as we go through this, we will not write a main function at all. It's included as part of the library. And so if we've done everything right, this is a very trimmed down version of where we're going to end up. I think we should be able to build this. And so I'm going to cd back up into just the unit tests folder. Let me clear this. So I'm just in, if we're looking down here, I'm just in unit tests here. And I'm going to collapse libcatch2 over here. So I'm right here. You can see all we have is the libcatch2 and the Cmake lists. And I think then what I'm going to do is I'm going to make a build directory. And this is important because you want to keep all of the build files from Cmake isolated so that they're easy to clean up. So I'm going to say make dir build. And you'll see that gives me a build directory over here. And now I'm going to cd into it. So now I'm in the build directory. And I'm going to say Cmake. So you have to have Cmake installed. If you've got the dev tools installed on Linux, they'll be included. The way you can do that is just sudo apt install Cmake, or you can do, I can't remember what the dev tools one is, but that's how you would install just Cmake. And to make sure you have it, I think you can do a Cmake version. And you can see I've got Cmake version 3.16.3. So great. So once you have Cmake installed and you're in that, we're going to say Cmake, and now we need to point it to a root source directory that has a top level Cmake lists.txt. And that's this one up in our unit test directory. So I can just do ... which is the indicator to go up one directory and look for a Cmake list.txt there. So let's see what happens. I don't know if this is going to work. Okay, no sources given to target unit tests. Great. So that's what I would expect because we haven't added any other code to this for it to run. Although I guess I would have expected it to build that main that just had empty unit tests in it. So, yeah, we'll keep going because I mean, running it by itself with no tests doesn't really help us with anything. So, all right. So now that's the baseline for our unit test. And if we expand build, you can see now it created this like Cmake files, this lib, it's got this cache.txt. And if you ever need to clean up anything from Cmake, you just delete the build directory and make it fresh. Like that's how you start over. So now we want to add some tests using the Catch2 framework. Well, the way I've done this in the past is under my unit test folder, I've created matching folders that match the components. And I found as a personal preference that sucks and it gets hairy because if I come under here and say new folder logging and new folder, serial logger, and then write tests, when you start getting more and more components and you're scrolling through your files over here, sometimes you get mixed up and you'll be in the logging of the tests and it's visually, I hate it. And that's kind of like the only reason I don't want to do it this way again, because I've done it that way in the past and I don't like it. So I'm going to delete these from here. And I'm going to put the tests right next to the source code that's going to be under test. And so under my logging component in ESP32, I'm going to say new folder. And I'm going to call this unit tests. So now for each component that I'm going to write for the product as we go through here, there will be unit tests right alongside logging. And eventually, I'm also going to have a test folder to take advantage of the ESP32 on device testing. And so that's why I'm going to call this unit tests. So in my mind, that's the indicator, like these are just raw C++ tests versus these are on device tests. So we're going to get rid of tests for now. And so now in our unit test folder, what we need to create is a Cmake lists dot text. Did I put a dot in there? Yes, I did. Okay, because we're just going to use Cmake to build our unit tests. And so what do we need to put in this? Well, we'll come back to that. We're going to need a Cmake list.txt to know how to build the unit test, but let's build our test file. So under unit test, let's do logging.test.cpp. And this is just a C++ file that will run tests against our code. And so what I'm going to do is the very first thing why isn't it typing in here? Here we go. Count include. The first thing I'm going to include is catch2 / catchall.hpp. Now I could be more specific, but for right now, that's the sort of v3 include everything from catch2. And that's what we'll need to run some of the tests here. And then the code that I want to test is just right above. It's this logging. We'll pick logging.h to start. So let's include logging.h. We need to go up a directory. It's relative, like that. Great. And now what we can do is we can write a test. And so I'm going to contrive one here, but let's just say test case. And this is this test _ case is a catch2ism. This is how we write tests in catch2. And I'll call this our first test. We give it a name, and then we can give it some tags. And so I'll just call this whatever. Test. Test is a bad tag to give a test. And then we just open bracket, close bracket. And then we can write our test code in here, our setup that we need to do, any action we need to take, and then verifying that the action had the desired outcome. And so there's a whole bunch of matchers and generators and things. I'm not going to go through it. This isn't a Catch2 tutorial, but one of the things in Catch2 is this require. And then inside of the require, you can put a statement of equality. Mellum, welcome. Sorry, a long time no see. Great to have you back. Okay, so I can do something like require true, which will always pass. Require false would always fail. I can say require 1 = 2, which will fail. So let's leave 1 = 2 as our test. Just again, we would fill this up with tests from our logging, But to just get started, that is by itself a very simple unit test that will fail. And so now we need to build that, and so we can run it. And so we're going to come back to our Cmake lists, and we need to tell Cmake, how do we build logging.test.cpp? Well, we're going to do a couple things. We're going to say add library, which means we want to build a library that we're going to link in to our Catch2 tests. And again, this might be a lot to swallow and digest right now, but stick with me. And we're going to give it a name. We're going to call it logging. We're going to call, this is a keyword in Cmake, static. We're going to make this a static library. And then I'm going to use a Cmake variable called Cmake current source dir. And you can use this anywhere in a Cmake list.txt file that says, give me the directory that I'm in right now. And so that's going to be this unit tests directory. And I want to go up from here. I want to go up one directory. So up into the logging component. And I want to include logging.cpp. Like that's the file that I want to build into our library, our logging library. Okay, so now that we have that library, we want to do an add library. And if you're a Cmake expert and I'm doing anything funky here, please let me know. Again, I'm not claiming to be a Catch2 or a Cmake expert. I found out how to get this to work, and it does work, and so I'm going with it. So we've got our logging library, which is compiling that logging.h and logging.cpp into a library, and then we need to create another library called logging tests. And this one we're going to make an object. We just want to make an object file out of it. And the source for this is going to be logging.test.cpp, that file that we just created in this directory. So now we've got two, we're telling Cmake to build two libraries, and then we're going to do target link libraries. And into our logging tests library, we need to include Catch2, and this is just from the Catch2 documentation. This is how you link in the Catch2 library. Because again, remember, in our logging.test.cpp, we're including Catch2 headers. And so we need to link that library in to our logging tests library. And then we need to say target link libraries, logging tests, private. Again, this private, again, keyword, read more in the Catch2 documentation. This is just saying that it's a private link in, meaning we're not re-exposing it publicly. Don't worry about that for now. Kind of like smoke and mirrors. Don't pay attention to the private. And then we need to link in the logging library that we just created up here. So in this contained unit of a library that is testing our unit, our logging, we need the library for logging.h, and we need the Catch2 library because we're using, this test case and require. So that is all we need in the Cmake list.txt to say, this is how you build the unit test around logging tests, if that makes sense. Hopefully it does. Okay, now that we have that, and one of the cool things about Cmake is how modular it is. Like every folder essentially that has sources in it knows how to build itself, like knows how to tell Cmake, this is how you build me. And so now what we're going to do is we're going to come back down to our Cmake list.txt in the unit tests folder. And remember, we were just trying to build it very simply before, but now what we're going to do is we're going to add another subdirectory. Say add subdirectory. And these can be relative paths to pretty much anywhere. And so I'm going to copy something that I have from before, and then I'll talk through it so you don't have to watch me type it. Okay, again, we're going to use the Cmake current source dir variable. So that's Now, again, it's the current directory that you're in, so that's this unit test one. We're going to go up a directory, into the components folder, into logging, and it's not tests anymore. It's now unit tests. Tests. Okay, and then we need to give it a name, and so I'm just going to call it log tests, and you'll see how what that influences here in a second. I'm going to save that, and now that we're adding that subdirectory and building all that up, now we just need to link it in with our unit tests. And so under here, we're going to call it logging tests. Now, where did we get logging underscore tests from? Again, that's back up in here. Remember, we created this add library logging underscore tests as an object. And so we can link that in as an object library into our unit tests. And I believe at this point, if I've done everything right and recreated everything that I spent so many hours messing with yesterday, we should be able to build. So if I do Cmake ++, again, I'm in the build folder. This is really important. Like where you are in the folder structure is important. And do Cmake ... I'm going to clear this so it's up a little higher. Again, in the unit test build folder, I'm going to say Cmake ... fingers crossed. Configuring done, generating done, build files have been written. Okay, now in the build, if I do an ls here, you can see that I have a Cmake cache, Cmake files, Cmake install, lib, log test, and I have a make file. So now make is another standard development tool that's usually installed if you're running Linux, and if you've installed, if you're running Windows, I haven't done this on Windows, so I'm not going to be much help for you there. It works very similar on Mac because you can install the dev tools very similarly to how you do on Linux. So now all I have to do is say make. Again, that's a build tool command. Make, similar to Cmake, is going to look for this make file, just like Cmake looks for cmake list.txt. And so I'm going to hit make. And now that's going to build our tests. And you can see right now it's building lib Catch2. This is building all the Catch2 test framework stuff. And fingers crossed I have not missed anything here. At the end of this, we should get an executable that we can run. And the way that Catch2 works is that it builds an executable that you can run that runs your tests, and it automatically builds in some command line arguments so that you can like list the tests, and it gives you a whole bunch of features. Again, check out the Catch2 documentation for that. But it looks like everything built, and it says built target unit tests. So now if I hit ls, you can see I have this executable over here called unit tests. And if I just run that, that is how I run my tests. So I build them, and then I just do / unit tests, and this will run my unit tests, and you will see I'll get all this pretty output. Again, I didn't have to write any scaffolding code or anything. All we did was write test case and put a require statement in it. And we could put whatever we want inside this test case to test the independent modules that we have. And so you can see that it failed, and it says require 1 = 2, and that's not correct. So I'm going to go ahead and change it to 1 = 1 to make it pass. And then what I have to do here is I can't just run it again. So if you see, if I run unit tests again, it's going to fail. And that's because when you're in C++, unlike if you've done this in like a JavaScript or another dynamic language, we have to recompile. So what we're going to do is we're going to say make again. Make this time is just going to rebuild the one object file that has our test, because that's the only thing that changed. And now if we run unit tests, all tests pass, one assertion in one test case. And you can see, just to show you, like we'll do require true to show you how this output changes. I'm going to hit make again, rebuilds them, and then I'm going to do unit tests. It's going to run again, and now you see it says 2 assertions in one test case. So it kind of keeps track of that, and it'll only show you in the case of a failure, will it show you like what it failed on? Like this is the line that failed. And so we've got unit tests. I'd say just that simple, but it's just that simple because I spent hours figuring it out before. So Cool. We have Catch2. Now we have Catch2 integrated, and now I can, to my heart's content, read the Catch2 documentation, and anything around Catch2 I can add to my test cases here. And again, when it comes time to test the serial logger, all I'll do is the same thing. I'll create a unit test folder, a Cmake list.txt, and then I'll come down into the unit test and I'll add another subdirectory, which would be the serial logger unit tests, link it in to our unit tests executable, and then I have my tests. Now, a little cumbersome if you're not used to testing in C++, but pretty slick if you've done C++ testing before. And then I'm trying to remember, I think I can do like, to show you the command line stuff that you just get built in to Catch. Like if I do unit tests, I think if I just do -L, yeah, it'll like all available test cases, and it has our name, our first test. This is the tag that we gave it, was test. We didn't write any of that code. That's all just built into the Catch2 framework, and we just get that as, you know, bonus to what we're doing here. So really cool. We have test cases. We can continue to write them and we can run them. Again, this is independent of the device. This is just testing like our business logic around our code. Great. That took a little longer than I was hoping. We got to do gcover. Like the second part of all of this is we want to do coverage for our tests. So like when our tests run, it's great that they all pass. It's also helpful to know how much code coverage we're getting from our code base. And to do that, we're going to use a tool called gcover. Now, gcov, G-C-O-V, is a base, was it a GNU tool that produces coverage information. And then there's lcov, which is a wraparound gcov, which will print out HTML output of your coverage. And then there's gcover, G-C-O-V-R, which is a Python application that does some more wrapping around gcov to give you a more readable console output or XML output or JSON output. It has a bunch of features around it, and that's what I've chosen to use for our project here. So we're going to test with Catch2, and we're going to do coverage with gcover, and eventually we're going to do profiling with Valgrind. We'll save that for another day, but let's do gcover really quick. So gcover, again, is Python, so the way you install it would be just via pip install. It's just you would do a pip install gcover, which I've already done. And so if I do gcover, I think I can do version. Yep, you can see I've got gcover 4.2, and it'll give you all the copyright and all that information with it. So great. So how do we get coverage information when our tests run? Well, we have to build into our test executable knowledge that it's going to create coverage. And that's actually pretty simple. And I'm going to just paste some magic in to make it happen for us. So in our unit tests, Cmake list here, right up below the project, I'm going to paste these in and talk about them really quick. It says set compiler and linker flags to produce coverage information. This is just standard GCC compiler and linker flags. And so I'm going to set this variable called GCC coverage compiler flags to these things. These, you can look these up, fprofile arcs and ftest coverage. And then I'm going to set another variable, GCC coverage link flags, to -lgcov --coverage. Those are just, that's the magic keyword to have when you run the executable with those compiler and linker flags. It will generate coverage information files, and I'll show you that in a second. And then I do the set Cmake CXX flags and Cmake's exe linker flags. These are, now that we've set these flags, this is how we make sure that we call them when the project is built. So again, it's some magic, and I guess I can put it in the description if you want to copy and paste it. Maybe I should create like a gist or something of all this. But anyway, this is just the copy and paste it because it's what you need. And then what that says is when you build this unit test executable, do it with these flags. And so now, if we look in the build folder, and I believe it's in Cmake, and then this unit test dir. Here are all the files that are, as part of this. Again, this is all generated by Cmake, but what I'm going to do is, now that we've changed Cmake lists, we have to not just do make, we have to redo Cmake. And this is where, just to show you how this works, sometimes what I'll do is I'll cd out and I'll just do remove srf build, like wipe away the build directory. You're not going to check that into source control, and then I just make it fresh. And this is sort of like a poor man's clean of the Cmake build stuff. Then I'll cd back into build. Maybe. And then again, I'm going to do cmake ... using the Cmake list from the directory above. It's going to build that all out. And so again, that gives me a make file. After I do that, I have to do make, which is the actual build. And again, if you're like a Windows person, Cmake would allow you to build a Visual Studio solution just from running these commands. And so then you could like open the solution in Visual Studio and build it that way. I'm just using everything via the command line because it's very convenient and a very Linuxy thing to do. Okay, again, it's gonna, because I wiped the whole build directory, it's gonna build everything again from scratch for the Catch2. And most of this is Catch2. Iterative builds, very quick, as you saw. Okay, and now if I do ls, you'll see that I have my unit tests executable back. And so let's run it. Not comma slash, / unit tests, enter. Okay, tests passed just like they did before, but now let's go into the build folder here, into Cmake lists, into the unit test dir. And if we scroll down, is it here? Oh, where do they put that information? I should have some. I don't remember where they go. Oh, this is where I'm gonna flounder, because it should have generated some coverage data files, and I can't remember where it puts those. Where does it put those? Here we go. Under log test, yeah, because this is the library under test. So under, again, digging down through, all this is generated by Cmake. There are a couple of files here, gcda and gcno. That is coverage information from when we just ran the executable. And if we click on those, it's going to say I can't read it because it's a binary. It doesn't understand the data. And so the tooling around this is pretty low level, but that's where gcovr comes in handy. And so all we need to do is we can just cd back up to our top level, stat feeder firmware. And I believe if we've done everything right, I can just say gcovr. Enter. And it will look down through all of the subdirectories, look for those gcda and gcno files, and it'll spit out something that looks like this, which is a huge, huge report of coverage. And now it says GCC code coverage report, and it'll tell you, here are the lines, the execution, the coverage. And now look at all this. This is crazy, like lots and lots and lots and lots of files. Well, what the heck's going on? I don't know. This is all, it's giving you coverage for everything that was linked in. Like you can see lib catch2 source catch2 catch message.hpp. Well, I don't care about the coverage on that for my unit tests, right? And so we need to tell gcovr to ignore some of those things. And I would have thought it would have done that because I've got a gcovr config. Maybe I wasn't in the right directory. I have this gcovr config right here, which says exclude, oh, that's why. Exclude tests lib. This is because when I was playing with it, I had called it something different. Right now we've called it unit tests. I'm going to collapse some of this build stuff down. And print summary, yes. Sort percentage. These are just arguments to gcovr. Now let's run it one more time, and it should pick up this gcovr config. Gcovr. And now you'll see a much nicer output. GCC code coverage report. And it's going to say in your components logging, unit test logging.test.cpp, it gives you the coverage of logging.h and logging.cpp. And you can see it'll tell you I have 0% coverage on both of those, which makes sense because remember, in our test file, even though I included logging, I haven't done anything to exercise any of the code. And it'll tell you all the lines that you're missing and your total coverage and everything like that, and gives you a little printout here. Really cool. Now, the last thing that I want to cover before we end the stream for today is it kind of sucks to like CD and make and delete and all this other stuff. And so in my case, using Visual Studio Code, I created some tasks and I want to show you those just briefly. It's fairly simple. If you come into the .VSCode folder here and you come into tasks.json, this is where I've previously set up my like build and flash and monitor with ESP-IDF. I just came down to the very bottom and I created these 3 new tasks. I have run tests, clean tests, and setup tests. Now, let's look at setup tests first. All I do is I say cd into the workspace folder, which is this top level stat feeder firmware folder, and I try and cd into tests build, which I'm going to change to unit tests build. If that succeeds, then I already have a build folder and I don't need to do anything. If it fails, I'm going to say or, and this make dir will only happen if this cd fails. And I'm going to make dir unit_test build. So I'm going to create that build folder where we're going to build our tests. Okay, clean tests. Remember, it's really just as simple as removing the build folder. And again, I'm going to rename this to be unit tests. So all we have to do to clean the test is just wipe out this unit tests, not that one, this one down here, this unit test build. We just blow it away. Our tests are completely clean. And then the run tests is kind of a long one, but you'll see it's just what we've been doing before. So we're going to cd into the workspace folder again, the top level stat feeder one. We're going to go into unit_tests into the build folder. And then we're going to call cmake ... You've seen me do that a bunch of times. Once we're done calling cmake ... we're going to call make, which builds our unit tests. After we're done with that, if it succeeds, we're going to run the executable, which is now called unit_tests. Once we're done running the unit test executable, if that succeeds, we're going to cd back into the workspace folder and we're going to run gcover. And that'll give us our output. And so, showing all of this in action, if I just hit Control-Alt-T, I get my tasks. And let's say, let's run clean tests. And watch the build folder over here under unit tests. I'm going to say clean tests. And you'll see now my build folder is gone. And then if I say run tests, it will say, oh, you don't have a build folder. Let me create it. Let me Cmake build it, then make it, and then run it, and then run gcover. And so we'll wait for the Catch2 stuff to compile. Let that run through. Remember, first time through, it takes a second because it's building all the Catch2 stuff. And we should be just about there. 80%, 90%. It will run it. You'll get all tests passed, and then you'll get the code coverage if all of the tests pass. So, and then it shows me the same thing. All the things I've used. Pretty cool, right? Now let's just final thing. Let's in our test case here. Let's create a log manager. Log manager equals log manager get instance. And then let's just make a call on it. It won't do anything, but let's make an info call of hello. So now we've exercised some of the code. Now again, we've got 0 and 0, but now we're not really doing anything that's a test. Oh, I need to add a tag here. Test. There we go. And actually, let's, I'm going to leave off the semicolon here to show you that the task, when we run tests, it's not going to, like, it'll only go as far as it can and then it bails out. Like, it'll say, oh, you've got a compilation error. So it's not even going to try and do the rest of like running it or anything or running gcover. It's going to say, fix the compilation error. So let's fix it. And then Control-Alt-T, I'm going to do run tests again. And now it should build just fine. My tests still pass, but now if we look, you can say, wow, look at that. I got 36% coverage and 100% coverage on the H in the test. And here are the things that I still don't have code coverage for. And it just, so now I'm in a spot where I can just iterate on writing tests. Write test, check coverage. Write test, check coverage. And hopefully improve the quality of our firmware. One other thing I want to show you is let's make the test fail. So I'm going to change this back to a 0 just to show you that it's not going to show you coverage in the event of a failed test run. I don't believe. Yeah. So it's going to say failed test case. This is the problem. You don't even get you don't get the no coverage unless you can make your test pass. And so that is going to do it for the stream today. I just wanted to show kind of the process. I mean, even after knowing how to do it, it took almost an hour to walk through that to show how now we have unit tests running against our code that we can, as we build components and business logic around our product, we can write unit tests that can be run. Again, eventually I'll offload this to like a Jenkins process on a different machine to say, hey, take my source code and run all of the unit tests against it. And then we'll also get to a point where we use the ESP32 to build device level tests that'll, I'm calling integration tests, that will run on chip and can do some testing for us that way. So hopefully that helps somebody. Again, the V3 of Catch2 kind of tripped me up a little bit, but this is like a bare bones, get you started with Catch2, gcov and gcover to give you code coverage and unit test coverage for your ESP32 project. So yeah, hopefully you found that helpful and informative. I'll probably come back and watch this at some point because I'll forget how I did all this. So thanks so much for joining, Sparky, Bellum. I'm not sure if either of you are still here, but thanks for anybody that's joined. As always, if you have any questions, feel free to put them in the comments below. Again, last time, I'm not a Catch2 expert. I'm still learning this, or a Cmake expert, but we were able to get all this put together, and I feel pretty good about where we landed in being able to test going forward. So thanks so much for watching, and have an amazing rest of your day.